see you too, Kevin.
Anyway, so the topic of this panel is 5G, which is a little bit ironic, because I think I've kind of developed a reputation for being kind of the dick party cop when it comes to 5G, constantly getting in people's cases for using the term, which I consider in a very wrong way. Right. And here we have a panel titled 5G, Exposure to Devices. But I'd like to establish what exactly we're talking about here when we're talking about 5G. I mean, I think both of us kind of agree we're talking about more of an ephemeral concept that's still in the standardization process. But tell us what is 5G? How does the industry, companies like Ericsson, are viewing it, and how the mobile industry is moving forward with, developing the standard?
Yeah, sure. There's really 5G in concept phase today. It's not a standard by any stretch. The ones who own the global trademarks for 4G, 5G, that's ITU, we're not really going to be in a formation where we could actually start to talk about 5G technologies till around 2015 or so. When you look at our industry, the cellular industry, standards come about every 10 years, right? And the peak of a particular standard in terms of its life cycle is about 20 years when it starts to peak. So these technologies come pretty quickly, and they stay around for a long, long time. So we start talking about 5G now because probably by around 2020, we're going to start to see actual commercial deployments of it. So we need about a 10-year cycle here to start inventing what that 5G technology is going to look like. So that's why it's kind of become topical within the cellular service.
So, where is that development work being done? I know Ericsson is in organizations like Metis, and there's been funding supplied by, different companies from Intel to the European Union are starting to invest money into it. What is that? What is the process, I guess?
Yeah, I think we're looking at technologies right now. You'll see in Metis, which is an EU-funded organization, which Ericsson is one of the founding members of, we're starting to take a look at what are some of the use cases? What would be some of the reasons why I would want to build a 5G network? And certainly, the headline capabilities of speed are definitely the ones that are attracting a lot of the interest from people who want very, very fast communication with us. But I think equally as important are going to be being able to serve the burst of connected devices that are coming in. And those aren't necessarily about speed, but they're much more about how many connections can I support in a mobile infrastructure. Moving from maybe around 5 billion by numbers of people, multiply that by 10 in terms of connected devices, and now you have 50 billion connected devices. So how do you take that crush of connections into the network?
Well, I've actually heard from yourself and many other people in the industry that in order for 5G networks to improve upon 4G, in order for them to become better, 5G networks actually have to be slower than 4G networks.
Yeah, in some cases.
Could you explain that, what that means?
In some cases, yeah. Well, if you take a look at, for instance, a sensor net that's actually doing monitoring, whether it's a set of wildlife or trees or whatever type of industry that you wish to target, you're probably going to have a number of sensors that are on and off at different odd points in time, because they can't always be on. They obviously are going to be consuming energy. They're not going to have a tremendous amount of traffic that they're going to upload. It's going to be very minimalistic traffic that's reporting on a particular status. So you don't necessarily need that high throughput. In fact, you want some latency. You want to be able to really start to gate the amount of traffic that's pushing through the sensors.
Do you get, what are the advantages to, by creating a lower latency, slower network, are you able to, add, put more overall capacity, put more overall sensors in the network than you would?
Exactly. You're really looking at the total lifetime of that sensor net. You don't want the battery capacity, the efficiency of that sensor net to actually fail within a year or 12 months. It should be out there for decades.
Well, I'm going, off of that strand. Every time a new generation of mobile technologies comes along, the industry kind of establishes, I guess, these goals of what they want to accomplish, right? So, 4G networks were obviously, or whatever you call 4G networks, the new LTE networks that have come out today, were building upon this kind of idea of the mobile internet that people tried to build in 3G to create, broadband connections over the mobile airwaves. Are those same goals going to be around for that next generation of networks, or are we looking at these different goals, like that connecting to 50 billion devices? What is the mobile industry going to be trying to accomplish with 5G that's different from 4G?
Right. Now, I don't think that we're going to lose the hook of people are consuming more. So we're definitely going to have to serve the increase in capacity that's the demand from just the day-to-day activities of liking that cat, taking a look at what my girlfriend's doing on Facebook. So I think that's still going to be you know, a compelling element of what 5G needs to do. So we're looking at moving from, let's say the peak of what I could do was in LTE Advanced at a gigabit per second. We'd like to get to 10 gigabits per second, as a for instance. In terms of the amount of capacity, I'd like to be able to serve 1,000-fold more. So in terms of a particular area, I want 100 gigabits per second per square kilometer. We're able to serve 500 gigabytes of consumption per user per month. So those are the types of numbers we're looking at from a user consumption. But to your point, there's this whole other element of, you know, how a machine is going to play a role in consumers within this new cellular infrastructure. And certainly when you take a look at those are actually going to increase the amount of capacity that we need to deal with in the amount of connections. So we need to tread on both sides of that fence. So we're looking at how do I serve both machines, humans, and then the different use cases underneath that are things like how do I get ultra-reliable connections? I mean, I know many of you guys probably have a cell phone, and every now and then those calls drops. That's probably not something that we want if I'm putting an industrial application on top of that. If I have a SCADA system with a 5 megahertz control loop that's operating some machinery that could devastate you know, a nearby population, I want to make sure that that's rock solid. I want ultra-reliable connections.
Maybe like an open-close switch for a dam or something.
Absolutely, yeah, sure.
What about the nitty-gritty of it? I mean, obviously, these standards are still being debated by organizations, but I mean, from what you're seeing so far, I mean, what are some of the technologies? How are today's networks going to evolve and change? I mean, you actually did a contributed piece for GigaOM kind of about this, how the telecom network will become radically different in the future. Can you give us a few details about what those changes might be?
Yeah, certainly. You know, Mark Andreessen had this great manifesto that he published a few years back talking about how software is eating the world. And certainly in our industry, as we take a look at infrastructure, software is certainly eating infrastructure. And I think one of the defining architectural changes for mobile networks moving forward are going to be their ability to be reconfigured and reprogrammed as opposed to redeployed for a new service. And that's going to be a very transformative shift. It's going to look a lot like how we have cloud systems today, which are multi-tenant. I'll be able to stack on different radio access technologies inside that mobile network. And so in terms of being able to serve, for instance, the industrial internet applications that are out there versus you know, your Facebook you know, checks that you're doing, of course, you know, the life cycle of a day, those will actually get different slices of the network with different technologies. Potentially one is going to be LTE, another one might be something that's much more ultra-reliable, that has a different type of modulation, a different type of capacity associated with it.
So what you're saying is that that 5G won't necessarily be a monolithic technology. There will be different types of 5G for different types of access, even on the same device, right? So if a different network or a different version of 5G might be carrying my Twitter traffic in the background versus the network that's streaming the video because they have different requirements.
Right. So, yeah, I think you know, some of the misnomers are that I'm just going to invent a new radio access technology, which is obviously frustrating sometimes because yet another different radio I have to put in my handset. I think one of the big shifts from a network perspective is going to be that it's going to be much more about how do I create a policy and control to create and allow multiple different access technologies to work together. So I'm going to be able to plug in both the services that I have today, let's say it's LTE, which is the 4G technologies that I have, Wi-Fi, in addition to potentially some new technologies that will be coming out that will be very ultra-fast, that will serve much higher consumption rates. Potentially it'll be a new machine-to-machine protocol that's much more lightweight, that will allow much more energy-efficient transactions to occur. So all of these technologies will kind of be housed in this new network with orchestration amongst them.
And I guess kind of one of the big question I always have, or the big statement I kind of always make in a lot of my stories when I talk about the progression of networks is this underlying assumption I think a lot of the mobile industry shares, at least I hope they share, that this progress forward will make mobile data cheaper. And this seems to be something that, I mean, probably a lot of people in this room are kind of skeptical about. I notice a lot of GigaOM readers are like that. They cannot believe that Verizon Wireless or AT&T would ever lower the price of mobile data. They never charge less for a gigabit because the perception is they're actually charging more over the years. I mean, do you think that we have, I mean, mobile data is going to get cheaper, and I mean, how much cheaper will it be? Will we get to the point where we aren't distinguishing between whether something is grounded in a wireline connection or a cellular connection? Or?
Yeah, that's a great question. I think there's a difference between the cost per megabyte, which has been going down, and the consumption per user, which is actually going up. So the cost per megabyte back in 2008 is probably 46 cents. In 2013, it's more like 3 cents to 1 cent, right, in terms of cost per megabyte. Now that's been falling about 50% every year, but what's happening is that we're actually consuming more. Our increases have gone up more than 50%, like 60%, in some cases 100%, depending on the time frame of the past 4 or 5 years. So net, you're paying more, but the cost per megabyte is going down.
And I mean, how much? I mean, do you have any projections as to like how we might be viewing the cost of data in the future? I mean, would we ever return to anything like an unlimited plan, or is that acceleration in the amount of data we're consuming going to prevent that from ever happening again?
And I think the friction point to consumption is obviously going to be cost. So if I want to have multiple different sensors hooked up into a cellular network, certainly I'm not going to pay $60 per subscription for every different device that's out there. That's not going to work out. So you have to have a different model where I can accommodate for machines versus humans. And that's not going to be $50. It might not be a penny per megabyte. It might be a quarter of a cent per megabyte, or it could be even less. But clearly we're going to have a price point that allows the economics of that service to actually thrive. And that's where these technologies do help us to drive to those types of cost points. Certainly from edge all the way to LTE in terms of technologies, the cost or the capital cost just to be able to deploy the networks have gone down significantly, where LTE is probably about 10–15% of what edge was in terms of cost.
Compared to the amount of capacity or throughput you can offer. Okay.
Yeah.
We had a couple minutes left. I wanted to see if there are any questions from the audience before I ask Vish anything else. There's 2 microphones in the back if anyone had anything. Okay, well, one thing that we've been talking about a lot at GigaOM is the rise of Wi-Fi networks, and how, Stacy, my colleague Stacy, has been on stage many times tonight, has talked about that. Maybe that the decisions we're using to pick mobile carriers are kind of off kilter. Maybe we should be looking for good Wi-Fi networks and then make our cellular carrier the secondary consideration, because so much of our traffic is starting to go over that much cheaper pipe. And I mean, Ericsson just bought Bel Air Networks, and you're obviously incorporating the Wi-Fi in the cellular networking architecture. I mean, how do you view the role of Wi-Fi and mobility in the future?
Yeah, Wi-Fi is definitely one of the resources that are out there to consume data and content. To disregard that is obviously foolhardy. But I think we have to understand that Wi-Fi, in terms of how it's developed through standards, is really just a MAC and a PHY protocol. It doesn't really define a network. And you really need to understand, how do I coordinate between all these different technologies in order to understand how can, at the point of consumption, choose the right type of radio access technology to receive whatever I'm doing, whether it's video, whether it's industrial applications, or other. When I look at 5G, certainly Wi-Fi will play a part in that. Is it just Wi-Fi that can dominate? Probably not. You have a number of different issues. There's an abuse of commons at 2.4 gigahertz. If you have a baby monitor next to you, it's going to crater all your capacity. 5 gigahertz has a little bit more of a quieter space to it in terms of technologies that are in there. But over time, that too is going to get saturated as more and more consumers start to become more and more dense in urban centers. So, is Wi-Fi the be-all, end-all in terms of wireless technologies? I think it's one part of the toolkit, not the only toolkit.
So not a situation where you view Wi-Fi as the primary access point and the cellular network as the fallback. You don't ever think we'll get to that point?
Well, I mean, we do consume probably more traffic over Wi-Fi than we do cellular today. So, in large part, you could say that Wi-Fi is carrying and is much more dominant in terms of an RF technology up there than cellular. But cellular is important because you can actually access it ubiquitously across any type of geography, versus Wi-Fi, which is very much a nomadic type of technology. You have to be pretty stationary in order to use it.
Yeah. Well, that's all the time we have for now, but I'd like everyone to join me in thanking Vish for
of a switch, but it's going to be covering the same topic. We're going to